Hello, this is Group 3 and our topic for our final year project is Financial Market Analysis Platform. We have created a web application in which the user can look after a particular stock and the data will be showed using the machine learning algorithms.
So now for the front end demo, let's have a look at our website. So this is our title, and here this is the autocomplete search bar. So the user needs to enter the ticker in this format as shown here. And also it is a suggestive search bar. So if a user starts typing something, it suggests based on what he has typed. So let's say we search for an Apple stock. So this will make three requests, two requests to our backend fast API server, one for stock info data and one for historical data. And one request will be going to the current API, which will get us the latest news regarding the selected stock. So this is the stock info component. Here we can see that this is the current price of the stock. This is the 24 hours low or high percentage change. Here we can see the change in the stock value in the past year and in the past day. This is a mini area graph. So here the user can have a quick look at how the stock has been performing over the past months or the year. If a user wants to have a detailed look at the stock, he can have a look at the advanced graph, which is a candlestick pattern. The data for this has been taken from the fast API. So to manage all this data on the front end side, we are using Redux as our store management tool, and the graph is plotted using Apex chart. So this is intuitive and the user can interact with it. We have annotated our predicted symbol or predicted candle with a year as predicted candle. So the user knows that this is the predicted candle which we have predicted and it's not the actual value of it. The user can interact with this graph if he wants to have a look at the time range and alter the time range based on how he wants. We can also have a look at what actual candlestick pattern is if he is new to the stock market world, and have a look at the news regarding the stock which he has. So this news has been taken from current API as mentioned earlier.
So our backend, which is the main prediction model of our code, relies on this, which is an LSTM cell. So LSTM is long short-term memory, which is a type of recurrent neural network. These are specialized neural networks which are useful for finding long-term dependencies, and thus they are useful for finding patterns in time series data. Also, the stored data that we are working on is time series data, so this intuition proves to be useful. This consists of forget cell and memory cell as well as an output cell, which are connected in cascading order. So we have multiple of these LSTM cells which give us the output. Now for the actual architecture that we are using in our model, we are here using two LSTM layers. So each of these have a number of neurons, and we have two such layers of the LSTM neural network, followed by a dense layer, which is a fully connected layer. And then we are adding some dropout to prevent overtraining of these layers. And then again, a dense layer to give us the final output, which is the predicted value of the next day's candlestick. For this whole thing, what we are doing is we are passing in the past 60 days of data as the independent data, and then getting the 61st day's data as the dependent data, which is being predicted or inferred. During training, we are using only the close values of these dots, but then the same logic or the same model is then applied to predict the open, high, and low values as well.
So we'll look at the scalars and the models used here. In the initial part of our project, we had only had one scalar which was causing issues in higher range price stocks such as MRF and other stocks. So afterwards, we created three scalars, each depending on the small, medium, and expensive stock range. So when the user puts in a request, it will select a particular model of scalar. Suppose the user selects TCS. That price range is in the medium price stocks, so the medium scalar would be selected, and correspondingly, the prediction will be done. Once we train the LSTM models on different price ranges, we save them in our main backend code. Then we import them using the particular module. Then we have used Fast API for the creation of our main backend API. So once the client requests particular stock, our main backend API sends a request to the Yahoo Finance API from where we get the data. Then after that, we select the particular model wherever the price fits in. Suppose if the user selects MRF, that would be in the expensive scalar, or suppose it selects a lower end stock such as Yes Bank or any other stock, it will be on the smaller side. Then we using the data from the Yahoo Finance, we predict the OHLC, and then we send the request back to the server. And in our testing, we got an approximate average error of 10 to 12%, and we have tested it on various range of stocks, MRFs which is in the expensive range, TCS which is the mid range, and Yes Bank and other stocks which are on the very lower end of the stock market. Thank you.
Thank you.